All right. So we're going to solve a kind of exception polynomial. And then we're going to use that method to solve some more normal polynomials in this exceptional way. And all together we're doing that just to develop a formula. And that formula shows us how we can solve any quadratic, meaning x squared equation, even if you can't factor it. Okay? Because if you can factor it, you already know how to solve it. But if you don't know how to factor it, we're at a dead end right now. That's what we're spending chapter 9 on, is how to solve quadratics with x squared where you can't factor them, right? The numbers are just random numbers they made up that absolutely don't work out, okay? All right. So we'll start with 9.1. Okay, there's kind of two big ideas here in 9.1. So solving quadratic equations by the square root property. All right, so the two big ideas are, just to do an example really quick, number 2 is x squared equals 100. Okay, how could we solve this? Right, we could, like in chapter 6, move it all to one side, factor it equal to 0, one factor is equal to 0, other factors equal to 0, or what grade do you have, Sydney?
You get the square root of x.
Shh. Sydney.
Oh,
yeah. Exactly. Okay. We square root both sides. Because what's the square root of x squared?
X.
Nice. What's the square root of 100?
10.
But we can't forget
The x.
x is already there.
Oh, the square. The square.
Square root's already there, right? We did the square root, hit that button, out came a 10.
Get rid of the square? Oh, I got rid of the square.
That's all perfect. Alright, so
Positive negative.
I think somebody may have said it, but okay, wait, so if you have a perfect square alone on one side of an equation, you can square root both sides. Okay, so that was what we did. But there's something we need to remember. Now, something we talked about in chapter 8.
Could either be a positive or a negative.
It could either be a positive or negative. Remember, and I don't want to go too much into depth in this again, but it's important to understand. The idea is that the square root, you don't need to write this part down, the square root to be a function is always a positive. Okay, when we take a square root, out comes a positive. Right? Square root of 9 is always positive 3. Okay? To be a function, the square root can only kick out one number. However, x squared equals 100 does have two solutions. What are the two solutions? Right? What can we plug in and have that work? Yeah, 10 squared is 100, but there's another solution. What else can we plug in?
Negative 10.
Negative 10. Negative 10 times negative 10 is also 100. So there are two solutions. If we just take the square root of both sides and get 10, we just lost one of our solutions in the process. So when we take the square root, we need to include both the positive and the negative answers that were already there. this equation had two solutions. So when we write in red the square root, we need to put the plus or minus. So remember, whenever you take the square root of an equation, you need to write a plus or minus. Okay, and that's so you don't lose the negative solution, so you need to remember that. So that's one big idea from this section. Okay, you're gonna get a perfect square alone on one side, then you're gonna square root both sides, and you're gonna put a plus or minus. And there we go, that's our answer, okay? So just to be clear, this means two separate solutions. Right, this means x equals 10 is a solution and x equals negative 10 is a solution. That's what the plus or minus sign means, okay? So that's one big idea.
So on our test, do you want plus or minus 10?
Either one's okay.
Okay.
Yeah, either one's absolutely okay. I wouldn't take off points. The one thing to be careful with, and it'll come up in this section, is what if I have x minus 1 equals plus or minus 10, okay? And I want to know what x is, okay? So there's two answers. So what's x equal to?
-1 and plus or minus 10.
Okay, so you could kind of write it that way. We're off by a negative sign, but yeah, you could write it that way.
Plus or minus 1 and then what?
So how would we solve it? It's x minus 1 equals something, so how would we solve it? No surprises.
You add 1 for both sides.
Mm-hmm. Yeah. Okay. The problem here is that I want you to tell me the actual answers. I want you to simplify it as far as we can. So what's the answers? What are the two answers?
X equals
10 plus 1, x equals negative 10 plus 1.
Well, I mean, tell me the actual answers. X equals?
Oh, 11 and 9.
Negative 9.
Or negative 9. The common mistake people make, so when you say, can we leave it as a plus or a minus? If you're combining things, I would not leave it like that. I would rewrite it as x minus 1 equals positive 10, or x minus 1 equals negative 10, and solve. Because the problem people get into, if they leave as a plus or minus, is if you're combining it, people write that's, and it's not, that's equal to plus or minus 11. That's not true. One of the answers does combine and get bigger, but the other, negative plus positive, cancels out, right? So, yes, you can absolutely leave it as plus or minus 10 if it's correct. But if you're adding a number to it, then you need to split it up and say one of them is positive 11, one of them is negative 9, right? So it depends. But yeah, you can always, if correct, leave it as a plus or minus, totally okay. All right, so the other big idea in this section is, and this, you put a line under this, totally separate. A big idea here, not the only one. Okay, and just to look at two separate equations, okay? Okay, so there's a big difference between these two equations. What's that big difference?
One is positive and one is negative.
That's not the big difference.
One
Has
has a,
three.
one has 3 terms on one side of the equation, the other one has 2.
Kind of. It's something to do with the terms, and not the number of them, because we'll move everything around, combine terms and stuff.
Maybe coefficient?
Coefficients.
A lot of people, no, not coefficients.
GCF, one
X
is
is just an extra exponent.
Kind of. So you guys see an x squared, right? Right away when you see an x squared, what do we think?
Factor,
Well, before we factor it,
GCF. Get everything over.
get everything equal to 0, okay? So here, you cannot isolate the x's since there is an x squared and x term, right? So if I moved all my x's to one side, right? So I'm gonna move my 2x over, move my 5 over to this side, just to see what would happen. Okay, this isn't what you would actually do. Okay, if I do that, what I would get is I'd get x squared minus x equals -2. That doesn't help me. I can't get my x's alone. So we learn in chapter 6, we move everything to one side, factor it, totally strategy right. So we move to one side, equal to 0, and factor it, right? However, on this one, look at this. +5 + 5, minus x, or x squared, I mean. We get x squared equals 9. Since there is only an x squared term, and not an x term, we can isolate the x's. So that's a big idea in this section. Is I said anytime you see an x squared, anytime you see an x to the third, move it all to one side, equal to 0, factor it, done. That's true, and it would work. However, if I have x to the 7th plus 5 equals 133, okay, I could move it all to one side and factor it equal to 0, but since there's only one term with x's, I could do this, -5, x is, or x squared to the 7th is 128. So since there's only one type of term with x's, I can get it by itself. So that's what I'm saying, this is a special circumstance. Not that common, but we're going to use this special circumstance and build on it, okay? And that's where we're going to build to this 9.3 quadratic formula. But the idea here is if we only have x squareds, we can get it by itself, and then we can solve it. Okay, just want to show you, that's what we're doing here. Okay. So let's solve some equations using this, okay? Here's how. Okay, in this section, we got 1, isolate the perfect square, okay? This can be just x squared, or could be a binomial square. Okay, whatever the perfect square is, get it by itself. Okay. Step 2 is, once you get the perfect square all by itself, square root both sides of the equation. Remember the plus or minus sign. I like my little remembers. I say remember so much. Didn't read that. Okay, so last one. Solve for x. And my one piece of advice there would be okay, and right below that, I'm just going to make a quick example to show you. So, the example right below that is, if I have x minus 2 squared equals 100, okay, the first step I would do there is I would go, okay. Oh, and I wanted to add one little thing. Take the square root of both sides here. Square root of x squared is x. Square root of x plus 2 squared is just x plus 2, because the square root and the squared cancel out. That's why we take the square root, right? I just wanted to make sure you guys are fully comfortable with that. But we take the square root here, making sure we have the plus or minus. So this becomes x minus 2 equals plus or minus 10. So this is when we go x minus 2 equals positive 10, or x minus 2 equals negative 10. Okay, so, and just to be really clear, not x minus 2 equals plus or minus 10, add 2, x equals plus or minus 12. Okay, not that. Just to be clear, split it into 2, so when combining the plus or minus 10 with a plus 2, you have 2 totally separate numbers. Alright, so let's solve a bunch of equations now, okay? We're just going to be doing a bunch of examples now. I went ahead and made the homework shorter. I cut out the Pythagorean theorem and the distance formula for this section. It's just extra stuff that doesn't build in chapter 9, and if we had time, oof, I would love to just lay down in a nice chair on the beach with you guys and talk about the Pythagorean theorem and the distance formula, and man, it's interesting stuff. But in terms of progressing forward in chapter 9, it's not going to help you, so I'm not going to have you do that in the homework. Alright, for those people who aren't here, it's a bummer for them. They're just going to have extra homework that's not going to necessarily help them in this class. Okay. Alright, so here's some, right? I should have added actually. And simplify your radicals, right? Should be in that last step, right? I mean, that should be self-evident now that anytime you get an answer, you should simplify it, whether it's a fraction, a radical, anything. If you can simplify it, simplify it. If you don't, I will give you most of the credit for a problem. But if you say square root of 9 is your answer, I'm going to say, yeah, that's correct, but 3 is the simplified answer that gets full credit. Okay. So 8 is x squared equals 27. 10 is 3x squared equals 75. So this is starting out this chapter, starting out this section. So what we do is Sydney on the first one, and then Frank, you can help me with the second one.
Okay.
Use square root of x squared equals.
We do. I write it in a separate step just to show you that that's what I'm doing, but yeah, you could just write it over the first one. Okay? And, Sydney, we would, right? Okay, so we got the plus or minus. A lot of people think in their head, they just write the square root here, the square root here, and they go, I'll get that plus or minus later. And even if that makes one extra mistake out of every 5 problems, that's still pointless mistakes, right? So always write that plus or minus the second you write the square root. Otherwise, for that step, you just lost your negative sign, even if all of a sudden it comes back later. Okay, so we got what?
Equals plus or minus. What would be the square root of 27? Or would you?
Yeah, so we have it as square root of 27, that's 100% the correct answer. However, now, that's where we say, can we simplify the radical? Okay, but that's the answer, that's correct. But if you punch that into a calculator, that's the answer, okay? But we would say that's x equals
Plus or minus 9 times 3.
exactly. And so,
X equals plus or minus 3 root 3.
perfect, so there we go. Okay, that's it. Right? Now on 10, we're gonna add one more step. We're just gonna add that step 1. So what do we do first, Ray?
So you write square root 3x squared? Oh, no, wait.
Yeah.
You leave the 3 out, so you do square root x2?
We will, as our second step, or we do our first step.
Isolate the perfect
He's working it out. How do we isolate the perfect square? How do we get it by itself? Right, you saw that x squared is the perfect square, and we want to take a square root of that, so what do we have to get rid of?
3?
Yeah, so how do we get rid of that 3?
Bring it over to the other side.
Yeah, how do we do that?
Oh, minus 3.
Ooh, that would be if there's a plus sign between it. Right?
Oh, divide by 3.
Yeah, so we just divide, just like if we were solving a normal problem, we divide both sides by 3. And now, that whole reason we did that is so that we have the x squared by itself now. And then, what do we do?
Then divide it square root, root x squared.
Yeah.
Plus minus square root 25.
There we go.
Which will be x equals plus minus 5.
There we go, done. There's no more simplifying to do there. Okay. Okay. So then we got a couple more examples. Now it's getting a little bit harder, okay? So expand your mind from 10 to 60 and look at 3x squared minus 5 equals 0. Okay, and now we're going to do the more general format of what answers are going to look like for this entire chapter. So x minus 2 squared equals 25. Okay. So, Nick, yeah, help me out with that first one. What do we do first?
Add 5,
Yeah, why?
because that's what you wrote down to do.
Do what? I didn't say right plus 5. That's not what I wrote.
Because leading coefficient is the 3, I don't know, because you want to get it separated.
Yeah, get what separate?
The x squared.
That's it. The big idea in this section is since there's no x middle term, we can get the x squareds by themselves. And then once we have x squareds equals numbers, even if the numbers are ugly,
Still there.
we can take the square root of both sides and we're done, right? Okay, so first as you said, plus 5 plus 5. And so now we got 3x squared equals 5, okay? What?
Divide by 3.
Divide by 3. Divide by 3. So, x squared equals 5/3.
Plus or minus? Or no?
Plus or
Okay,
minus.
so now we got to square it.
Now, ooh, not squared. We have x to the 4.
You got to square each side.
That'd be x to the 4?
You got to put a root thing over each
Yeah, square root
side. Square root.
each side. Okay, so we square root each side.
And that gets rid of the x squared, so be x equals square root 5/3. Plus
Oh
or
man, I
minus.
guess you could get half credit.
Or, no, could we, oh, okay, so then we can do x equals plus or minus.
There we go, plus or minus. That
can
gets
you-
both answers.
Do you want to separate them or do you want to keep them together?
If you could simplify it, you would separate. So We sadly had to cut out section 8.4, as I said, in this one little summer course. We just were cut for time because when the final exam has to happen. But in general, the one little caveat here is in Math 263 as you move forward, you're not gonna leave this as is, only because when you split this up to be square root of 5 over square root of 3, we never leave a square root on the bottom, just so we know whether or not it's a like term with something else later on. So we would rationalize the denominator. And again, we're not doing this, but you would multiply it by square root of 3 on top and bottom, so it'd be square root of 15 over square root of 9, or square root of 15 over 3. That would be with the denominator rationalized. But in terms of 5 and 3, there's no simplifying that happens. I will 100% accept that as a correct answer.
So if it was something in there like, like 25 over 5.
Yeah, if it was 25 over 5, you'd simplify it. Yeah, because 25 over 5 could reduce down to 5, or if it was 25 over 7, square root of 25 is 5. So either way, simplify it, yeah, as much as you can. But as soon as you get down to some prime numbers, or just non-perfect squares that don't have any perfect square factors, you're done. Okay, so 20.
Okay, so in parentheses x minus 2, right next to x minus 2 in parentheses, because it's x
That
minus
would be if
2.
we wanted to multiply it out. So in general, yes. So if you ever see a problem that looks like polynomials and stuff, yeah, multiply it out, move it to one side, equal to 0, factor it, but we're using a special method here, which is not one, yeah, we usually use. So remember, we want to isolate the perfect square first. And oh, it's already isolated, as you said, so what do we do next?
Get that square root.
Yeah. So whoops. So get that in the square root, okay, and?
And then put an equal sign.
Yeah.
5, square root 5.
Well, let's do it in steps, but you're right, okay. So we start with 25, then we,
And then you go down, and you square root it.
because you should, whatever you do to the left, you gotta write on the right, and,
You go down and,
wait, we're not done with this step first.
oh, you get rid of the square.
Oh, we're not there yet.
Plus 5.
There's this big space here.
Oh, plus or minus.
Yeah, we gotta put it, as soon as we write the square root sign, that plus or minus is automatic. Otherwise, you immediately are missing half of the problem. Half of the answers are gone now. You can only get, what, half credit on the problem? Maybe like 60% on the problem or something. But as soon as you lose half of your problems, you lose like half of your credit. Okay, so yeah, you need that plus or minus. Now, I've still got both answers. Okay, so over here, what do we get?
X minus 2.
Exactly, because the square root and the squared cancel out, equals.
Plus or minus 5.
There you go.
And then you'd add 2.
Mm-hmm.
So it's x. So it's x equals positive 7 or x equals negative 3.
Exactly, but I would do it carefully by splitting it up. You're right, those are the two answers. I would split it up to be like this. And then I would, yeah, add 2 to 5 and you get 7. But just doing it in your head is just asking for extra mistakes. And please, math gods, give me just 1 or 2 extra mistakes. So here's x equals negative 3, right? There we go. Okay, so exactly, 7 and negative 3 are the answers. Yeah, so that's what we're building up to. And this is what section 9.3 is all, or 9.2 is gonna be about, completing the square. This is going to be the second half of every problem in 9.2. Okay? The steps I will write for 9.2 will be do this, solve like 9.1. Right? So I'm gonna add some new steps and then say the rest of it solve like 9.1. Because this is the type of problem we're going to get really used to solving. The one little hiccup I will add is your answers are a little too clean right now because there's no square roots in your answers. So let's say the problem didn't work out as nicely in terms of numbers, but same solving, okay? So here's 26, same method, but now the numbers don't work out nicely, okay? And again, I'll do one more where the numbers don't work out nicely, but we do it the same way. So 28 is y plus 7 squared equals 5. Okay. So, Ruth, what would we do first? And then Dan, I'm gonna have you help me with the second one. Or why don't you go first, Dan? Okay, so 26, what would we do?
You get the square root of both sides.
Okay, so we take the square root of the left, x minus 3 squared. We take the square root of the right, got it?
And then that would be equal to x minus 3
Oh, half credit.
I mean,
Man, heartbreaking.
plus minus.
Plus or minus, oh, okay. Now we got full credit. Okay, what is it equal to?
X minus 3.
Yeah, because these cancel out, okay.
And then you split it so it's
Wait, is it equal to?
plus or minus 3 times 5.
So it's equal to 15?
So it's 3?
So we would just leave this as square root of 15, can't be simplified any further. You're right, 3 and 5, there's no perfect squares in this, so we just leave it like that. And so here is absolutely, and I'm just gonna take over for this 1 minute here, you can split this up, absolutely, and say, whoops, positive root 15, add 3, you get x equals 3 plus root 15. Or you can say x minus 3 equals negative root 15, add 3, I don't know why I'm writing the number first, it doesn't matter, that's just the way we usually write it, but it doesn't matter if you write the number first or not. I mean the integer first. Okay? So absolutely you can split it, and I think that is the safe bet. However, since you're not actually combining the 3 and the root 15, since they're staying as separate terms, you could just write x minus 3 equals plus or minus root 15. You can add the 3, and you could write your answer as x equals 3 plus or minus root 15. And since you're not combining them, that's totally okay, right? However, when you're combining them, do not do the add 2 and then get plus or minus 7, right? That's the mistake people make, is they don't split it up here and they get plus or minus 7. That's not correct. But if it's a square root, since we're never actually putting them together, that's a perfect way to put your answer. Exactly the same as doing it separate though. So one is not better or worse than the other in any way. Both are perfect, full credit. Okay, Ruth, help me out with the second one.
So then you're gonna square root the y plus 7
Okay, so square root it. Yeah,
equals plus or negative square root of 5.
perfect, okay, and then what do you get?
And then you want to put y plus 7
Exactly, that square root, square cancel out.
equals plus negative square 5.
Yeah,
And then you're gonna minus 7.
yeah. You get?
And then by equals 7. Maybe 4 or 7? Negative 7
Yeah.
plus negative.
Well, plus
Or
or
plus
minus.
and minus and square root of 5.
There you go. If you say plus and negative, that makes me think like 5 plus a negative 2, which is totally different than 5 plus or minus 2. This is one value equal to 3. This is two values equal to 7 and 3. Right? So one is different than the other for sure. And sorry if I'm nitpicking vocabulary, but the way you say it kind of frames how you think about it. Language frames the way we think. And so definitely be careful with how you're wording it. Alright, so one last step we're going to add here. And it's not a huge leap. I'll just do 2 examples. Is instead of giving you a problem like this as is, oh, that eraser is brutal. There we go. Okay. So instead of giving you a problem like 26 or 27, where this perfect square is already factored, equals 15, they're just going to take you one baby step past that, and they're gonna say, okay, now what I want you to do is factor the perfect square. Then solve, okay? And it says in the instructions, factor the perfect square, then solve, and every time it clearly gives you a perfect square, no rearranging needed. Okay? This whole rearranging and making a perfect square, that's the entire next section. Okay? 9.2 is all about rearranging and making a perfect square. Right now, all they're going to do for a problem like 32 is they're going to exactly write a perfect square. So here's 32. X squared plus 4x plus 4 equals 25. Okay? So normally, when we see that problem, we move it all to one side, equal to 0, factor it, two separate answers, right? Special circumstances, they're giving us special instructions here. We're going to factor the perfect square. Here is the perfect square, and it is as clear as this in every problem. There's no other surprise tricks here. It will clearly give you the perfect square trinomial equals a number. Okay? So you can factor that. What is that perfect square?
X plus 2 times x plus 2.
Exactly. So x plus 2 squared equals 25, right? And you need to start getting comfortable with that perfect square formula. However, you could have just gone, well, adds to be positive 4, multiplies to be positive 4, that's positive 2 and positive 2. That's x plus 2 times x plus 2, which is x plus 2 squared. So you absolutely could factor it any way you want, right? But either way you get to a perfect square. And that's the only new step. Then it's like normal. So just take it from there.
It'll be square root of x plus 2
Exactly.
plus and minus,
Yeah.
right?
Mm-hmm.
X plus 2?
Almost. Wait.
Wait, what?
Not done on the last part.
Oh, square root of 2.
Exactly. Let's square both sides. Okay. So then we get.
X plus 2
Yeah.
equals 5. What, plus and
Plus.
negative?
Yeah. Exactly. Plus or minus. We have two answers here, and then.
And then you minus 2
Mm-hmm.
from the x plus 2. And then you cross out the 2 2's.
Mm-hmm.
And you get negative 2 plus, oh, x
Mm-hmm. Yeah.
equals negative 2 plus negative 5,
Okay. So negative 2 plus negative. Yeah.
right, or no? And you do on the other side?
Okay.
I don't know.
Okay, so when you got to there, because you're actually combining them, I wouldn't do that first, because yeah, it's confusing me. You have plus or minus 5 minus 2, you're like, what? I don't understand. So that's when you would split it up to say x plus 2 equals positive 5, x plus 2 equals negative 5. If it was a square root where they're not actually going together, just leave it as 1, it's okay. But you could split it up. There's no right or wrong to either one, just be careful. Okay, so split it up, and now, as you said, minus 2, clearly this is x equals 3, and then minus 2, a little less clearly, but hopefully clearly. Okay, yeah, so you helped us all the way through, but yeah, don't get caught up right there. Okay, so, erase my little slash through there. Perfect, so one more example, just like that, and then we'll take a little break. All right, here's 38. That's x squared plus 2x plus 1 equals 7. So again, they clearly give you a perfect square. They don't hide it. It's right there. So factor it with the x factor if you want, but you get to, exactly, x plus 1 squared. And again, if you're not comfortable identifying that yet, that's an area we will practice more today. But you could absolutely go up to the side and say adds to 2, multiplies to 1, positive 1, x plus 1, x plus 1. So that's x plus 1 squared. You can definitely do it with an x factor and then go right back to the problem. Okay, now that it's a problem like before, Gerardo, what do we do?
Square x plus 1.
Not square.
Whoa.
So what's the vocabulary, how do you say it, but right idea?
That's, you put it under square? I don't know.
Under the square,
Yeah.
one word missing there, under the square root, right?
Square root.
Because if you square something, it gets bigger. Squared means to the second power, right? So we're taking the square root, we're trying to find out what went to the second power. Okay, so square root both sides and?
Plus, minus?
Yeah, plus or minus,
Plus
okay?
minus.
So what do we get?
X plus 1
Yeah?
equals 7 plus plus or minus
Yeah?
equals 7. I mean square root 7.
Square root of 7. That's not perfect square root, so we just leave it as is, and then?
X plus 1. X plus 1 equals 7.
Well, but not 7. So what are you doing in this next step? It's up to you. We can go 2 directions with this.
Minus 1.
Yeah, okay, minus 1. What do we get?
X plus 6. X plus minus.
So we just get, since we can't combine whole integers with square roots, we would just leave them separate. So we would write that minus 1 and then say plus or minus square root of 7. If we could combine the things, like a 2 and a 5 we could combine, that's when we split it into 2 and say either it's positive 5 or negative 5, and we'll get 2 totally separate answers. 3 and negative 7 look like they have nothing in common, right? Whereas over here, since we can't combine these, we just leave it as 1.
Okay.
Right?
Something new.
Yeah, there we go.
I was about to ask you that, so
Yeah.
if it's a squared
Yeah.
number, then you could do that part. But
Yeah.
if it's not a square number,
Yeah.
that's fine.
And so you could absolutely, though, say x plus 1 equals positive root 7, split it to x minus 1, x plus 1 equals negative root 7, subtract 1, get x equals negative 1 plus root 7, great. And minus 1, x equals minus 1 minus root 7, awesome. Okay, and you could even write it in the other order. You could even write negative 7 minus 1, root 7 minus 1, that's okay. But again, we always write the square root second. So if I write, for quick example over here, if I write square root of 7 plus 1, that looks super vague, right? That could either be the square root of 7 plus 1, which is 1 value, or it could be square root of 7 plus 1, which is square root of 8, which is a completely separate value than this. Okay, so that's why we always write the 1 first, is so this crazy, sloppy square root doesn't just wander off, okay, and then suck things into its black holeness. Alright, so let's take a little break, give us 10 minutes, come back, and then 9.2 builds exactly on this, and it's a pretty challenging section. And then 9.3 gets easier on Monday.